Okay, so while you guys are working on those, I will be handing out graded quizzes. Hopefully lovely answers. There could be some shock value here. I don't know. We'll see. Ready? Number 1, the answer is actually -2. That might be worthy of discussion. Number 2, I think the great challenge of number 2 is to make sure that you maintain rigorous notation, right? That everything is well communicated. In the end, you just get A equals 5, right? And I apologize for number 3 kind of being on the bad spot. It says, oh man, I can't even read that because of where it is. It says, we don't know about the continuity of F, so you can't make a conclusion. So Reese just like let the cat right out of the bag in the first 10 seconds. He's like, what about continuity? That's the question, isn't it? Yes. Since we don't know anything about continuity on 3, we can't say anything about any IVT-like thoughts, right? Number 3 was kind of aimed at the IVT, and more specifically, it was aimed at the condition. Like, has the one condition for the IVT been met? And the answer is, we don't have a clue. So we can't necessarily make a conclusion. If I told you that f of x was continuous or that f of x was a polynomial, now we could actually come up with a value. What'd y'all come up with? What? 1, 2, 3? 3 times if f is continuous? So, but we don't know about continuity, so we can't really make a decision.
How did we get -2?
How did you get -2? So number 1, I would say, honestly, like if there's like a scale of difficulty on limits questions, this would be up there pretty high. This would be like a 8, 9, 10. This would be a really challenging question. It is composite, and you saw on your quizzes you had a much simpler composite. This is a tougher composite for sure, because the outside function, in this case g, is not continuous at an important spot, right? Mm-hmm. So here's the deal. If I'm going to do this, the first thing I'm going to consider, let me just write over the top of this, if it will let me. There we go. So if I'm going to do this, kind of my first step, if you were going to like put this in like step by step, I would do the limit as x approaches 0 of f of x, right? I would do the limit of the inside function. And so we know that f of x is 5 minus x squared, and the limit as x approaches 0 of 5 minus x squared, y'all came up with? Bless you, 5, right? So then maybe you said, okay, maybe some of you might have said g of 5, and that would definitely not be exactly what we're going for. What we'd be going for is this. We'd be, say, like step 2 would be the limit as x approaches 5 of g of x equals, and this maybe was where you said, hey, the left-hand behavior is heading towards -2, and the right-hand behavior is heading towards 2, right? Therefore, the limit does not exist. But there is a subtle, important twist to this, and you have to be really good at graphing to see this. The truth is, as I look at this, my first part of my effort here, the limit as x approaches 0 of f of x is definitely 5, but let's dig a little deeper, and I'm going to sketch this out over here. This is a graph of f of x. Would you guys agree with this? That this is a graph of f of x. Sorry, I didn't put arrows on my axes. You get it? Okay, so here's the thing. It's not just that x approaches 0 of f of x gives you 5. It's actually you're approaching 5 from numbers that are less than 5. Think about it like this. No matter which direction I come from, like if I start here, if I start right here, I'm trying to get towards 0. I'm at like -1. Now I'm at 1. Now I'm at y equals 2, y equals 3, y equals 4, 4.2, 4.8, 4.9, 4.999. All of the numbers that I'm saying are less than 5, are they not? Now as I approach 0 from the right, you'll see the same pattern. -1, 0, 1, 2, 3, 4, 4.2, 4.8, 4.9999999. Every single number I mention is actually less than 5. So, I come back down to my step 2. I actually need to amend it slightly. I have to say, yes, as I approach 0 on f of x, I'm heading towards 5, but I'm heading towards 5 from the left. Right? Because didn't I approach 5 from numbers that were less than 5? Like if I made a table for all these little purple dots over here, wouldn't every single number in the table, no matter which direction I approach 0 from, wouldn't every single number for the output of the table be less than 5? So I'm approaching 5, but it's from numbers that are less than 5. So it answers the question, okay, I'm approaching 5 for the inside function, I get it, but am I approaching from the left or the right, or is it neither? Is it kind of both? Once you start to think about the graph of f of x, you got to come to the conclusion it's actually definitely approaching 5 from the left, right? Sorry, correct? And so since I'm approaching 5 from the left, I'm actually approaching 5 on this branch. So I'm heading towards -2. Like I said, this is some pretty heavy lifting in the world of limits, right? This is not an easy question. A few of these have showed up in the AP test over the last 5 or 6 years, but not every year. I'm just trying to stretch your limits, so to speak, on limits, right? Get it? This would be a tough one. And so I was kind of hoping that y'all would look at me and be like, what, -2? That makes no sense. So we'd have a chance to talk. I don't know, have I done a good job explaining it? It's hard. I don't know, maybe it might take a few more tries at something like this, and there will be a few more tries, so don't worry. Okay, Kaylee.
So would it only work like this with a parabola? Because if you had a linear graph, it would be from...
Now I think we're looking at D&E, right? Because we would say, hey, we're if it was 5 minus x, let's say, I think the end result would have to be D&E because we are not approaching with a linear graph. We would not be approaching 5 from the left or the right. It would be from both directions. So then you went to this, discontinuous graph. You have to consider both directions, and that's where you get the different behavior. So it really depends on what is the nature of that inside function. So yeah, it could be something else entirely if that was the inside function was something else. Yeah, for sure. Okay, anybody else? Question or thought? All right, fair enough. So again, just a reminder, this RQ2 notation here simply means that question in a slightly different form could very well show up on Review Quiz 2, which will be, I don't know, a month from now, something like that. Okay, well, let's move forward. If you did, and I hope you appreciated it, the John Ross video, we'll actually do it again, watch it again in a different light for tomorrow. I hope that you enjoyed that, and hope that you learned a little something from that. Would it be fair to say that the John Ross video was mostly about average rates of change? Would that be fair? Okay, so that is our focus today. And there might be some times during our class, and maybe sometimes during the John Ross video, where you might have thought, shoot, this feels like Algebra 1. Anybody feel that way? Kind of was like Algebra 1 or Algebra 2, perhaps, something like that. Sorry, I don't know why this is not showing up. I've got something else entirely on my screen. Hopefully it'll work. So flip over to the ice cream cone question, if you haven't already. I know it's not up there, but hopefully it'll show up soon. So it says, 2 p.m., Bobby had consumed 2 ice cream cones. I really like Bobby. I wish I could still behave like Bobby and be in relatively good shape, but it's just not true at this point. 5 p.m., he had consumed 11 ice cream cones. What was the average rate of change of the number of ice cream cones on the interval from 2 to 5 hours? Show the work leading to your answer. I should say your, not you. And include units with your answer. So again, if you really dug deep on the John Ross video, you got to admit this is just like the John Ross video, right? So hopefully this will work for you. Take a minute, see if you can figure out what that average rate of change means. And if you're sitting there thinking to yourself, I didn't watch the John Ross video, I hope he doesn't ask me if I did or didn't. I'm not going to ask you right now. All I'm going to say is that tomorrow we're going to be looking a little deeper, like I said, and whether you watch the John Ross video or not is going to become even a little bit more important. Just saying. So you should consider that intro activity for tomorrow. But for now, we're talking about Bobby and his problem with ice cream. Or maybe it's not a problem, I don't know.
Should this have been easy, Mr. Anderson?
Well, easy is such a complicated word. I hope that it was the mechanics. I hope the mechanics were very easy for you. I can't speak about the concept. I mean, somebody could stare at this for 10 minutes and say, I don't have a clue where to start. But I am hoping that if they knew where to start, the rest would be very easy.
Very easy. Absolutely. It's too easy.
Okay. So let's talk about Bobby. I'm hoping that after 2 minutes here, if we're all doing okay, this would have gone pretty well. So the key phrase in all of this when we're kind of considering the question, great, Bobby has a problem, but what do I do? What are the words that tell us kind of here's what you need to do?
What was the average rate of change?
Average rate of change. That's the key phrase. What was the average rate of change? When you see these words, I'll highlight these in red. Average rate of change. Can anybody compare that to another skill or concept you've learned way back? It's slope. And we're going to actually use the word average slope because in our class, we're going to be talking about slope at a point, which is different than average slope. Yeah, Hunter's right. When you see average rate of change, we're talking about slope. So I would say, I would start off with this. I would say it's the change in the outputs divided by the change in the inputs, right? If you think about slope. So the ice cream is definitely going to be the output. So I would say 11 minus 2 because his final number of ice creams was 11. His initial was 2, right? Start of the time we're paying attention to Bobby. And that would be divided by the change in time. What would you say the change in time would be?
3 hours.
3, which aka 5 minus 2. I mean, honestly, does that not look like slope from Algebra 1? That's all it is. Average rate of change, average slope. We will use this. We'll absolutely use this in a number of ways in our class. So, of course, that's 9 divided by 3. So his average rate of change would be 3. And what would be the units that would go with that? Cones per hour, yeah. For those that are maybe unsure, did you know you can get the units right off the numbers? Isn't this right here 11 ice cream cones minus 2 ice cream cones? Hopefully it's no wonder then that the top part of your unit is ice cream cones. And this is 5 hours minus 2 hours. So again, hopefully it's not surprising that the bottom part of the unit is per hour. You should be able to get the units right off your numbers. The units should always agree with whatever math you're doing. Okay. What do you think? Any questions there? All right, so 3 ice cream cones per hour. That sounds lovely. I happen to like ice cream. Maybe not so good for your health. Okay, number 2, a little bit of a different question. One element is the same. So please tackle number 2. It says the number of dogs at the dog park, T hours after the dog park is open, is represented by D of T. Selected values of D of T are given in the table below. So part A says, and I apologize, I don't know why my computer is so slow with the whole switching of screens, but it just is. Part A says, what is the average rate of change of the number of dogs at the dog park? Oh, shoot, it should say dog park, not at the dog. On the interval 2 to 5. Hours include units. And then B is where it's different. A is just like number 1. B says, estimate the rate of change of the number of dogs at the dog park when T equals 6 hours. So B is pretty different. And please take a look at 2A and 2B. Like number 1, did you guys do 24? Oops. Do you guys do 24 minus 10? We're doing 2 to 5, right? Yeah, 2 to 5. 24 minus 10 over 5 minus 2? Yep. Okay, so 14 thirds. And of course, that's what? 4 2/3. 4 2/3. You don't have to do that. And please, for goodness sake, don't do a mixed number. If you wanted to say 4.666, 6 repeating, that'd be fine too. But I personally just prefer 14/3. What kind of units would you put there?
Dogs and hours.
Hours. Yeah, I couldn't remember what the time unit was. Dogs per hour? Sure, that makes sense. And that's just like number 1, isn't it? I'm going to give you a softball there. B. So B is actually hinting and foreshadowing at something we'll start to talk about tomorrow. It says estimate, with this being an important word, it says estimate the rate of change of the number of dogs at the dog park when T equals 6 hours. So did you notice the subtle difference? It wasn't from 2 to 5 or 3 to 10 or whatever. It was at 6. So I don't know, anybody pick up on the foreshadowing here? If I'm asking you for a rate of change at a one particular point in time, say that one more time. It might be. It may or may not be. If it was, it would maybe make a little difference on the word estimate, like we were talking about. We don't know if the graph of n of t is linear or not linear or piecewise. We don't have a clue. But when I start to say, find the rate of change at one particular time, what concept? It's actually a derivative. We're starting to kind of hint at a derivative. And we'll hint a lot more strongly tomorrow. Okay? So, a couple of folks, I think, came up with a good strategy here. The word estimate, a little uncomfortable with that sometimes, right? It's a little outside your comfort zone, but it's not that far outside your comfort zone. If I'm asking you to estimate the rate of change and all you have is a table, what might you use?
The rate of change you just solved for.
Okay, but I disagree that it would be the exact same one, because if I'm trying to estimate the rate of change at 6, and what I used before was from 2 to 5, 6 isn't even in that interval, right? It seems like I could do a little bit better. And so we want to think about what is the best way I could estimate it. I mean, so Hunter said, why don't we just use from 2 to 5? But y'all see how 6 is right there. 5 to 7, 7 to 5. Do you see how 6 is right smack in the middle? Now, we don't have any idea if this is curvy or linear. We don't have any idea. And so in the end, is our answer going to be exactly the right answer? We don't know. But that's what an estimate is, right? Like if I had Joe stand up and I said, Joe, I estimate you to be 9 foot 10 inches tall. 9 feet 10 inches. That sounds about right. You don't look at me and say, you either need to have your eyes checked or you don't understand feet and inches, right? But if he stood up and I said, Joe, I'm guessing right around 6 feet.
No, you.
And Joe might say, well, it's actually 6 feet and 1/8 of an inch. Wouldn't you look at me and say, well, that was actually a pretty good estimate, Mr. Anderson? Whereas my 9 foot 10 was terrible. But 6 feet would be like right in the ballpark. This is the best ballpark we can do to use that 5 to 7 interval that Carter mentioned. So I'm going to say my best estimate for this would be 35 minus 24 over 7 minus 5. I'm picking the 5 and the 7 because, like I said, the 6 is right in the middle there. It seems to make the most sense. So that would be 11 divided by 2. It'd still be dogs per hour for my units. So that would be my best estimate of the rate of change of dogs at the dog park when t equals 6. So I think I might be jumping the gun a little bit here, but I have a phrase for you. And I might use a word that you're a little unfamiliar with. The word differentiate means to find a derivative. So this is a lot of foreshadowing here. So here's the phrase. I'll plant this in your mind right now. If you can't differentiate, and differentiate is a word meaning find the derivative. If you can't differentiate, that's fine. Just use the slope, right? Of what? What did we just use the slope of?
The interval around it.
Interval around it. I'm going to use this. This is going to be the actual term. You guys ever heard of this? Secant? Secant line? Anyways, that's foreshadowing a lot of tomorrow. We'll be using secant lines and tangent lines to do all kinds of stuff. So if you can't differentiate, that's fine. Just use the slope of the secant line, and that's what we did. Good? All right. So I got one last example. It's number 3. If you guys would flip over there, this has multiple parts to it, using some of the same things we've been talking about here today. So check it out, please. Number 3 should be the last one. We're using, instead of, I hope you guys are noticing the different representations here. Number 1 was actually a function rule, right? I gave you the analytical rule. Number 2, I gave you a table to work with. And then, of course, number 3 is a graph. So I'm going to try to give you lots of different representations. We'll hopefully be able to make connections between all these things as we move forward. So here it is, number 3. You'll see that A and B, it's asking for an actual precise answer. C and D uses the word estimate again. So consider what that means. I think with a graph, it has a certain connotation. It's a little bit different than if you've got a table. Things equal 0, it usually means something important.
What'd you do?
Hope you guys are all comparing answers and coming up with some good things. That is an actual very important number, right? When things equal 0, we're going to find it's like super, super crucial. So what's happening to the graph of G at that point?
It's like starting to go down.
Yeah, it went from up to down.
Yeah, but it exactly x equals 4, so it's just fun.
0. Slope is 0, yeah. Yep, we will use that fact repeatedly this first semester. When you've got a high point, a nice smooth high point, the slope up there at that high point, or low point, 0. So yeah, good. Good find for sure.
Well, the slope of that entire line is -3, so I think at any point.
But doesn't it include from there to there?
It does include from there to there, yes.
So like, wouldn't that have to include
to
the circle
4.
too?
Yep, the second, or I guess the first point in your slope would have to do with the circle. Agreed.
Oh wait, no, I have positive.
Questions? We're gonna look at some solutions here from y'all in a few minutes. Just actually a few moments here, but anything else?
It doesn't say estimate though. We did the sandwich one on the estimate one. Because remember on this one I just did ×6, but then I said estimate, so we did that one.
All right, Joe, how you doing?
I'm doing pretty good, I think.
The estimate ones kind of got you hung up a little bit?
A little bit, yeah.
Okay. It's different than what you're used to doing,
It is.
right? So I think you find the mechanics to be I don't know. I think the mechanics are often pretty simple, but it's the concept underlying it where you're like, whoa, what am I doing exactly, right?
Totally get it.
What does this number mean? So we'll talk. If I say something confusing, it's probably my fault. Probably not your fault. Let me know.
I'll let you know.
Okay. All right. Hey, let's look at some answers here. A. Let me do this first.
Then why'd they stop for like a decade and a
Come on, computer.
half? Broke and decided to make more money, but Star Wars movies.
Which one came first? 1, 2, 3, or 4 through 6? 4 through 6.
Keep getting the beach ball of death.
Prequel is the same.
No, 1 through 6.
Normally not like this.
Anything after that is not worth watching. Why? Please.
I'm about to give up on the technology. Just beach ball right now. All right, maybe that's good. Yeah. So what is the average slope of g of x, slope being average rate of change in the interval from -3 to 4? Would you guys be okay with this? If I said x equals -3 is right about there, and 4 is right about there. Those are those two endpoints of this interval on which I'm trying to find this average rate of change. So then what I would say then is that this line segment connecting those 2 points would represent my average rate of change, my average slope of g on that interval. Is that fair? Like if I could just find the slope of that green line segment, I'm good. So what I'm going to say then is to find that average slope of g, I'll just put average slope equals, so my y2 would be from this one here. This is the point 4, 4. So it would be 4 minus, this up here is -3, 9. So it'd be 4 minus 9 over 4 minus -3, -5/7. That make sense? Does it feel like you just got transported back in time to algebra 1? Like that's all it is. So please, if it asks for average slope of a graph or a table or something, that's all you're doing. Please don't overcomplicate that. B says, what is the slope of g? And then it uses that phrase, at x equals -1.5. And this gets squarely at the question that was kind of brought up by Gavin and some of the guys at his table there. They're like, on that previous one, they said, well, if this graph was linear, right? Well, what's happening on the interval where we have x equals -1.5? That graph is? Linear. So wouldn't the slope on any part of this line, it really wouldn't matter which point I picked, would it? That's one of the qualities of a line, is that the slope is constant. So no matter which point I picked along that line, the slope is going to be the same thing. So if I could just find the slope of that line, that would be good. And the slope is what? -3, down 9 over 3. So I would say this one would just be -3 because I was able to find, and of course -1.5, I gave you a decimal on purpose because it's like right there and you're going to think, what? But if you realize it's part of a linear part of the graph, you just use the slope of the line. Question, yeah, Hunter.
What if I just just found the points at x equals -2 and x equals -1 and then found the slope from there?
Totally. Yeah, if you pick any 2 points you know that are on that line, that'll work fine.
But I didn't realize that it was a line. I wasn't thinking like, oh, it's a constant slope. We're just going to do it in the middle. Like,
You got lucky. You got lucky is all I would say there. Yeah. Well, and sometimes you'd rather be lucky than good, right? Look like you totally had it, even though maybe you didn't. It's okay. If you showed good work, or, you really didn't have to show much work there because it's just a line. I'm sure you're able to do that pretty quickly. So, okay. And then the other two, C and D, said estimate the slopes. And again, please pray for my technology here. I'd really like to draw this out here. I thought, I'll just tell you the answers. I thought for C, hey, there we go, maybe? No, that's not what I wanted. I thought for C, the answer was like roughly 1-ish. And if somebody had said like 1.2 or 0.8, I have a really hard time arguing with you. We could actually figure out exactly what it is. But I think 1 would be a pretty reasonable estimate there. And I just got that from finding that point right there and saying, you know what? Looks like it's roughly a slope of 1. That was very much of a rough guess. So I wouldn't give you a question like this and expect you to get the exact answer I got. However, I will say, so I would say here 1 makes sense. For D, I would really want you to come up with my answer for D. What'd you come up with for D?
0.
I think 0 is the best answer. Isn't that, at least to the best of your eyesight, isn't that where the circle turns around from going uphill to downhill? And whenever something like that smoothly goes from uphill to downhill, or the other way around, downhill to uphill, you should have a slope of 0 at the high point or the low point. And so I think 0 is probably your best answer there. Although I got to admit, it's based on a graph, and sometimes graphs lie to you. So if you said, I thought it was 0.00001, what am I going to say, right? Probably not going to say much other than, why are you making life difficult for yourself? I don't know. So guys, we've got about 3 minutes here, and I realize that is not a ton of time, but I was hoping that